case. Last time, this is what we have seen, a schematic explanation of quantum theory. We have physical objects. We have two kinds, two families. Either you are particle or you are wave. Wait, where is it me? I don't see me in my screen. This is not good. Stop, bro. Let's do it again. All right. This is a schematic explanation about quantum theory. We have two kind of objects in our universe. Either you are particle or wave. You cannot be both at the same time. You have to choose. Once you born as particle, you will be forever a particle until the judgment day. There is no way for you to change your identity to be a wave. Tapi Pak, bagaimana dengan umat Nabi Musa? Mereka jadi kera. Perangai mereka yang menjadi kera. Mereka tetap manusia, tapi perangainya ke kera. Bagaimana kera berperangai? Mereka telanjang. Mereka melakukan hubungan suami istri di jalanan. Itu namanya perangai ke kera. Maka Allah mengutuk umat Nabi Musa yang melanggar hukum sabat menjadi manusia berperangai ke kera. Di mana kalian melihat manusia berperangai kera? Di peradaban barat. Siapa yang membawa bikini ke sini? Peradaban barat kan ya? Jadi janganlah menjadi kera. Kembali ke quantum. So, particle and wave. Either you are particle or you are wave. If you are particle, then I must study you using equation of motion for particle. If you are wave, then I will study you using equation of motion for wave. This is what we call as quantum classical mechanics. This is the small part. Now you can flip. If you are particle, I will study you as a wave. If you are wave, then I will study you as a particle. What do you call that? As flip. That's quantum theory. If I flip your identity, not your gender, but your identity, your behavior, now I'm going to use quantum mechanics. In this sense, classical mechanics is a special case of quantum mechanics. So quantum mechanics is more general than classical mechanics. All right. So this is quantum theory. This is quantum theory. If it is a particle, study it with equation of motion of wave. If it is a wave, study it with equation of motion of particle. Okay. Does it make sense? Of course, it does not make sense. You are a particle. Why should I study you as a wave? You are a wave. Why I should study you as a particle? It doesn't make sense. So, there is no physical reason why things work like the way things do in quantum realm. Paham ya? Jangan tanya. Do not ask why. Ketika kita menggunakan quantum mechanics, kita bisa menghitung energi, kita bisa menghitung orbital, kita bisa menghitung singlet, spin state, dan seterusnya dengan cara yang doesn't make sense. Karena kita akan memperlakukan elektron sebagai gelombang, which is not true. But again, do not ask why, just do it. Paham ya? There is no physical reason. So Dr. Mark, you have to explain to your student, please don't ask why. It is as it is. That's the answer. Now, if you settle yourself, that we are going to study electrons as a wave doesn't mean that electron is a wave. Okay, electron is still electron, but I'm going to study it using equation of motion for wave. If you already settle it, then the next question is, what is the wave-like equation of motion? Apa persamaan gerak gelombang untuk partikel? Before we answer that question, the first question that we need to understand is, what is equation of motion? What is equation of motion? Dr. Mark, are you still following me? Can I see you? Yeah, great.
Yes, get follow you.
What is equation of motion? Yeah. Kalau gini cocok ya. Belum kesana. This is the most famous equation of motion. What is that? The second law of Newton. Hukum kedua Newton. That law says as follow. You can read that. You know exactly what it is. Alright? Ini sekedar pengingat buat kita semua. Hukum 2 Newton, bukan hukum Newton 2. Kalau hukum Newton 2, artinya ada 2 orang Newton. Newton pertama ini hukumnya, Newton kedua ini hukumnya. Begitu juga dengan penyebutan wakil 2 dekan, bukan wakil dekan 2. Kalau wakil dekan 2, ada berapa orang dekannya, Bu Vera? Ada 2. Apa yang sering kita pakai? Ya, itu salah. Kalau mau juga pakai strip di sininya, wakil strip dekan tapi D-nya tidak kapital lagi. Alright, forget about that. Nah, ini contoh. Jadi kita lihat ya, there is an external force, and then we have mass kilogram, and we have the change of position over time twice, or we call it acceleration. This mass belong to particle. This acceleration also belong to particle, but the force belong to something else. The force does not belong to the particle. It belongs to something else outside the particle. That's why we call it extension, external. What it means? What does it mean? Outside of the particle. This is the example, yeah? Example. The motion due to the gravitational force. So we will exchange, we replace this with this. Okay? The external force may depend on time and position. May depend, also may not be depend. Depends, ya. Bisa fungsi waktu, juga tidak bisa bukan fungsi waktu. Another example is spring force. The particle moves due to the Hooke's law, hukum Hooke's. Ini dia. We only change the left side of the equation. The right side of the equation remains the same. Tetap tidak berubah. Yang berubah hanyalah gaya eksternal. And the last one is the electrostatic force. Hukum Coulomb law. Ini gaya Coulomb. Alright. The equation of motion has solutions, may have one solution or more than one solution. And the solution of equation of motion for particle is always like this. It is always like that one. Jangan tuh kelihatan. The position over time. The position depend on time. The position of what? The particle. Where is particle at the given time? Di manakah particle pada waktu tertentu. Example, this is your favorite formula. Position of particle S0, the initial position, plus half of AT square. You know this formula, right? This is what we call it, the solution of equation of motion. Ini fungsi ini ya, Umbu. Ini fungsi. Solution of equation is function. Ya, baik. This is equation of motion of wave. So previously we see for particle, this is for wave. And the most famous one, for wave, we have a lot of equation. For particle, we only have one equation of motion for particle, whatever particle is, either it is atoms or stars in our universe. Only obey one equation. F is equal to m is, that's it. You only need to understand one equation to understand how the universe works. Oh, amazing. But for wave, we have a lot of equation for wave. One of them is Maxwell equations. But the most fundamental wave equation written by the French physicist called D'Alembert, this is the formula. You have U. I will not say it. Just look at the in the screen. The green one, the blue one, we simplify using Mathematica, simplify using Nabla or Laplacian operator. Yeah. And then in the right side, you see this one. What is U? U is the solution. Never mind. We don't need to understand right now. But the one thing that I need to emphasize it to you, there is one unique trait, satu karakter yang sangat spesial from wave equation. If the equation does not have this trait, it cannot categorize as wave equation. What it is? It relates position domain and time domain. You see, the left side, the blue one is position domain. So that's why we differentiate it over position. In the right side of the equation is time domain. So that's why we differentiate it over time. So now we are talking about time and spatial dimension. Dimensi waktu dan ruang. Spasial, bukan spesial ya, spasial. Spatial. And the wave equation relates the position domain and time domain. That's the unique trait of wave equation. If one equation does not have this trait, it cannot classify itself as wave equation. Understood? And if we look at the equation of motion for particle, look, it does not relate time domain and position domain. It only talk about position domain, geometry. Where is it? Where is it? Where is it? But for equation of wave, we are talking about where is it and when it is. All right. And due to the unique trait, the solution always be like this. There is no other way. The solution of wave equation always the combination of sin and cos function. But the solution of a particle can be anything. It can be anything except sinus. You see, if it is sinus, must be wave. So, Dr. Mark, I hope you still can follow me. So the solution for the wave equation always the combination linear of sin and sine and cos sine. All right. Now let's move to our main problem, the wave-like equation of motion for particle. Bahasa Indonesianya, persamaan gelombang persamaan gerak gaya gelombang apa ya? Wave-like itu kayak gelombang, tapi nggak benar-benar gelombang. Wave-like seperti gelombang untuk partikel. And what is the wave-like equation of motion for particle? A lot, super a lot. But we only need to study one of them, is Schrödinger equation. Schrödinger equation. You will see this kind of equation. You don't need to remember this, but you need to understand why we call it as a wave-like equation of motion for particle. This equation must contain information about particle. And what is the identity of particle? Mass. You see it? Mass. If you look at the Alembert equation, there is no mass here. There is no mass, but there is wavelength or frequency inside v, speed. There is no mass. Not mass. Mass. Mass is something else. So, if you look at the Schrödinger equation, you will find mass. It means it is for particle. Now, how do I know that this is wave? How do I know this is wave? Look at the solution. The solution contains time domain and position domain. It must be wave. If you remember hukum 2 Newton's second law, there is no position inside the solution. The solution is where is it, but not when it is. When is it? The solution of Schrödinger equation contain time and position. If you look at how we wrote inside the variable, look at the variable function C, T, R. Why? Because time is the zero dimension. Dimensi ke-0 adalah waktu. Dimensi pertama, X. Dimensi kedua, Y. Dimensi ketiga, Z. Dimensi ke-0 apa? Time, yes. So, you know that we have M as the representation of particle. Also the field, the energy of potential energy. Potential energy here, it belongs to particle. You never talk about potential energy for wave. If we talk about wave, we never talk about potential energy. Potential energy is always for particles. Caca ngantuk. Announcement, Caca is sleepy. And the solution must be this way. The solution must be this way. Okay, don't worry, you don't have to remember this. Everything, you only need to understand why we called it a wave equation for particle. And we can assume that the wave function can be split into solution of time domain and position domain only. We assume this. And we can do that because why? Because there are a lot of equations before Schrödinger came up with this equation are similar to this equation. So they already finish this, how to solve this equation. We only take it from the mathematics field. And if we split domain of time and domain of position, we will end up with the time independent Schrödinger equation. Everything is similar, except in the right side, there is no time anymore. Every single term in this black box is position domain. while the time domain, we put it in somewhere else, this one. And the amazing thing is this time domain is always be like that forever. But the C, the position domain, can be changed depend on the potential. Depend on the potential. Next, we don't have much time. This is the simple case, hydrogen atom. This is how we model hydrogen. We are going to apply Schrodinger equation for hydrogens. So that's our topic right now. Usually you have nucleus, one proton, and one electron. And usually people will put the origin outside these two systems, these two particles, somewhere in here. Of course, you can put origin at the same position of nucleus, like what we do usually for our solar system. We will put sun as the 0.0.0. So that's why we consider that every single thing rotates or beat the sun, but it is not true. You can say that, okay, my 0.0.0 is Earth. It is also possible. Who says that our Earth orbiting the sun? We say it because we put 0.0.0 at the sun. Can I put it in my hand? 0.0.0 at my hand? Of course, you are selfish, egoist. Everything orbiting around you. Of course, it is possible. The sun will move around you. Jupiter will move around you. But we call you as egoist. All right. So this is the first way. The first way we model hydrogen. There is one electron and one proton. And if we model hydrogen like this, we will face a problem called two-body problem. Two-body problem. Another way to model hydrogen is we delete proton. There is no nucleus inside hydrogen, only one electron moving around of the potential field, Coulombic potential field. How many particles now in this figure? Only one. So we are facing one body problem. If we consider proton inside the hydrogen atom, we are dealing, kita berurusan dengan two body problem. Pak, bedanya cuma satu. Alright. Look at how difference between one body and two body problem when we put it into Schrodinger equation. Which one do you prefer? This is two body problem. This is one body problem. Two body problem, each electron, each particle has its own coordinate. Okay. And then the position, the wave function, the wave function now depends on two position. What we call it? Resonance, interdependence position. And can you solve it? Difficult. Sure, we can solve it, but it is difficult. But if we delete proton, we only deal with one particle. Look, M1, M2, okay? M1, M2. Potential also depends on the position of proton and electron. But now, if we only consider one electron, we only have to deal with one body problem, which is simple. Of course, we, as a lazy person, we are going to choose this one body problem. We don't know about Dr. Mark because Dr. Mark is, I want to two body problem. Because Dr. Mark, listen to me, student Dr. Mark. Dr. Mark is a student of Kasai Sensei. Kasai Sensei has a software called Naniwa. Naniwa consider hydrogen atom as two body problem. So very good, very difficult. Only Dr. Mark knows this. Naniwa, the software called Naniwa. Because it is so difficult, nobody uses it anymore. including the mark. All right, so because we want to make it simple, we will delete proton inside hydrogen. Cool, eh? We don't see that anymore. We don't, yeah, I know this is hydrogen, but to study hydrogen, we delete proton. Of course, it is not correct, but I remind you again, there is no common sense in quantum mechanics. If it works, let it works. Do not ask why. This is the philosophy of quantum. I told you now. If I tell you now, if it works, just let it works. Do not try to change the code. Okay. Now, if we look at the Schrodinger equation, the time independent, you will find that the thing that makes difference between one system with another system is the potential energy. The kinetic, this part, nabla square, is universal. Whatever the system is, the formula is the same. But for the potential, change when the system change. For the hydrogen, the potential comes from the proton. We delete proton, but the field is still there. Kita hilangkan proton, tidak ada lagi proton. Sebagai partikel proton hilang, tidak ada massa proton di dalam Schrodinger equation, tapi medannya masih ada. Medannya itulah yang akan membuat elektron memiliki energi potensial. Mudah-mudahan habis kelas ini akan saya jelaskan kepada kalian di sana ya. So I will go a bit fast. This is what we call as Coulombic potential field. Satuannya, the unit is volt, joule per coulomb. How many volt baterai? This what we call it, this volt, like battery. And who own? Siapa pemilik medan potensial ini? Who generates the electric field? Proton. Okay. This is electron. Electron will feel, akan merasakan the field as energi potensial. Potential energy Q times the field. Saya ulangi ya. Siapa pemilik V? Cuma ada dua, proton atau elektron? Proton, bagus. Tapi proton nggak ada lagi ya. Siapa pemilik energi potensial? Elektron. Elektron pemilik energi potensial. Proton sudah tidak ada, diganti dengan medan potensial. Di dalam medan potensial tidak butuh massa. Medan potensial adalah gelombang. Radiasi kita sebut. Paham sampai di sini ya? Nah, radiasi potensial dirasakan oleh elektron. Karena dia merasakan radiasi tadi, elektron sekarang memiliki energi potensial. Kalau dia tidak merasakan medan potensial, elektron tidak pernah memiliki energi potensial. So the potential energy arrives, you have an potential energy because you feel the potential field. Right? I will continue. So this is the hydrogen atom according to the time-independent Schrodinger equation. We have M, mass of electron. We have potential energy of electron. Q capital, Q normal. Q capital is charge of proton, E. And Q small q is the charge of electron, minus E. Hukum Coulomb ini ya, ini hukum Coulomb. Energi listrik dari Coulomb. Apa ini? Atom hidrogen. Ini adalah atom hidrogen menurut persamaan Schrodinger. Okay, I will go next. Now, we have to choose the coordinate now, because if you look at the solution is position domain, spatial domain. And spatial domain need coordinate. We have a lot of coordinates like Cartesian coordinate, cylinder coordinate, but we choose spherical coordinate. Why? Why? There are a lot of reasons why we use spherical coordinate. For example, traditional thinking. Traditionally, we thought that atoms looks like a ball, bola. Historically, before Schrödinger used this equation for hydrogen atom, Bohr already explained atom using his own model, and Bohr used spherical coordinate. But the correct reason, the correct reason why we choose spherical coordinate, because now we are dealing with wave, and wave is circular motion. Circular motion always used by default, by nature, use spherical coordinate. So that's the correct answer why we use spherical coordinate. Why? Because now the electron that we are talking about, it behave like a wave. Wave is part of circular motion. Tahu circular motionnya? Gerak melingkar. And if it is circular motion, by nature, secara alamiah, we will use spherical coordinate. That's the correct answer. All right. And now, since we use spherical coordinate, we also can split the wave function. This is what we call wave function, yeah? Only radial wave function and azimuth wave function. R and Y. This is for radial, because you know that if you use a spherical coordinate, the position is given by radial and two sudut, two angles. Angular, yeah. This is R, radial. This is two angles. And these two angles, we call it azimuth. So that's why now we have two functions for our to replace our wave function, radial and azimuth. Okay. For radial function, we use Laguerre functions. Laguerre function. What it looks like, but it looks like so ugly. I don't want to show it to you. Just remember, what is R? Laguerre function. That's enough. And for the azimuth, we use spherical harmonic function. Mathematics, this is from mathematic field. And Laguerre function, they have two parameters, N and L. N and L. We don't talk about quantum number yet. We don't know. It will become quantum number, yes, but right now we don't know it is quantum number. And for the spherical harmonic function, it contains parameter L and M, which is also quantum numbers in the end. But now we don't know it is quantum number. Why I don't see mark here? Okay. Oh. This, so, ada something. Wait. Ada animasi ya? Kenapa kok ada animasi? All right, so we have this. The solution of Schrödinger equation for hydrogen is like this. This is the wave function, the solution, R, and there are two parameters, N and L, depend on the variable. This is variable, this is parameter. They are different. Parameter and variable, they are not the same. And then we have azimuth, Lm, theta phi. This is variable. M and L are parameters. And this, how do we say this? This is the wave behavior of electron in hydrogen atom. So what we are writing here, what we are looking at here now is the wave behavior of the electron in hydrogen atom. So if someone say to you, what is the wave function of hydrogen? What does it mean? It means that this is the mathematical formula to explain the wave behavior of electron. If you go through, you will, in the end, you will find this is only sine and cosine. That's it. But the formula is a bit messy. We don't want to show it to you. The parameters M and L determine the electron's energy, while parameter L and M determine the electron's motion, how it moves, zigzag, straightforward, or like spiral. The pathway of electron inside atom determined by L and M. How much energy electron possess determined by N and L. So that's why N, L, and M can represent the wave-like behavior of electrons. And finally, we will explain next week when we put it the number of N, L, and M, it matches with spectroscopy observation. Spectroscopy already has their own notation to explain the orbital. And finally, quantum also ends up with the same number for the same orbital. That's why NLM becomes quantum number. So stop here because it is already 12. Also, it is about we have to take it slow. Next week, we will enter the main menu, DFT, density functional theory. I will upload this slide because this slide less joke, less, what do you call that? Or maybe the two previous one, a lot of jokes, so I don't want to share it with you because yeah, it is not good. But now you can have it, take a look, and use it for the next meeting. Inshallah, I will give it to you right after this class. And next week, we are going to enter the main menu, density functional theory. And before I conclude, I also need to explain to you why we have to do module A a little bit slow. If you look at the question, the task, the module not only asks you to calculate, but also to tabulate. After you tabulate your number, your result, you do some small analysis. And we teach you the module, through the module, we teach you how to do the basic of analysis. We call it comparative analysis. You compare between one column and another column. So you have to take it slow. You have to understand, like what Dr. Lucia explained to you. If you take column 1 and take column 4, basically you want to see how the method works between Hartree-Fock and DFT using the same basis set. If you look at column 1, 2, and 3, the same method but different basis set. So basically what you are going to do is basis set effect. How the basis set affect your result. Also, the module asks you to read the literature. We use it only one literature here, the CRC handbooks of physics and chemistry, because we realize we will use it many times from now on to compare our calculation with experimental results. So that's all for me. Dr. Mark, perhaps you want to add some more comment?
Thank you for the lesson today. And also, I think my students, they have not received their ID yet, or Muna yet. So maybe they may not be able to access the e-learning at Unair. Maybe later you can share the notes to me so I can share with them.
Yeah. Why not? Oh, what happened? Bila-san? Where is Bila-san?
Yes, Dr. Fabian. I'm still I just rechecking again the student from the format. There is one that hasn't registered yet. There is one. So Ningpre said that she waited. She wanted me to submit
so
all
she
of
will wait.
them. Yeah,
I
all of
see.
them at the same
Oh,
time. So
Student.
she just don't go back forward like that.
May I know who's the student who has not registered?
As I remember, it is Nur Shazwana.
Shazwana.
Yes.
Yang belum daftar lagi. Google Form. What's the name? Nur Shazwana, is it?
Yes.
Siapa tu? Semua daftar. There's no such student. Is that ada nama ni student ni? Shazana. Is it Shazana?
Yes, it is.
Shazana. Siapa tu? Siapa Shazana angkat tangan? Tak ada. No such student. So there are total of 38 students, right? 38.
From the latest spreadsheet that you sent me, it is 35, Dr. Mark.
35.
Yeah.
Who have registered with UTM. There are 3 more students who have not registered with UTM, but they have registered with UNAID. So total there are 38.
Oh yeah, the three extra are already registered from
okay.
The last update.
35, there are 1, right? Can you give me the name later? So that I can check with them.
Yes, Dr. Mark, we can send you.
Okay. So please register because we are waiting for, they are going to register only when everybody has registered. Is that understood? Yeah. If you delay, then we would not be able to access to the e-learning at Unair. Okay. Right. I think that's all for me. Yeah, maybe
all
later
right, thank you.
share the recordings with me.
Yeah, I will.
And I can put in my e-learning at UTM, so it's easy for the other 35 students, they're able to access.
This slide, I will convert it now, and then I will send to you right away after this meeting. Don't worry.
All right. Thank you. Thank you so much. I think that's all from me.
All right. I will give it to Dr. Lucia because you open the things, right? The class. Please, Dr. Lucia.
All right. Thank you, Dr. Fabian. Okay, so that's the conclusion for the class today. Before we end this session, we will take picture again. Nabila, please help. Please open your camera, guys.
Tata, please open your eyes.
Okay, for Anissa, Sania, and Andreas, please turn off your camera if it is possible.